Right, from the last video, we have talked about some basic information of similar triangle. Now we're going to test it. So they are in a certain forms of it. One will be one overlap the other. So say for example, I got this one. Excuse the drawing because it's just a sketch. I always say that my drawing is not into scale. All right, so we got a triangle. Actually, what we can see is a triangle here. They're counting the triangle games now. Okay, and then we have D, E, F. So first of all, what we can see here is a pair of common angle. They will always be the same, right? So let the people know what we are doing. So angle F angle GFH, GFH, and angle DFH, DFH is equal because they are common angle. And then we have given the right angle here, so just write it down, whatever they give you. FDE. This is equals to 90 degrees. Further information they given to you, and it's given. Last but not least, we know the third angle will be the same because the 2 is the same. The third one will be angle sum of triangle because angle GHF should be equals to 180 minus 90 minus angle GFH. Yeah? And at the same time, we have angle, at the same time, we have angle DEF equals to 180 when we're looking at this one. 180 degree minus 90 degree minus angle EFD, right? DFE will be better because it is the same angle, but we will DFE. All right, it's the same angle, just we have to make sure it belongs to the same triangle. Now, because 180, 180, 90, and 90, and this angle is the same because it's proved there, therefore it will be equals to GHF. Now we got 3 sets of triangles, so we have, therefore, the triangles are similar. Just have to be aware, sometimes they give you 3 pairs of triangle, you just have to match them up. Sometimes you have to need a step, such as like this one, you need to find a third one to prove that they are the same. So basically, if a triangle, you have 2 pair, corresponding angle is the same, the third pair should be the same because it's based on some other previous geometry we have learned before. All right, the other one is finding the length of it. So what we're going to have is, we got, let's do this one. So this is another triangle here. I want you to prove that whether they are the same. For this case, we only got a triangle, so we have to find size. Lucky, we have right angle here, so we can have our calculator to find our Vx, which is this side, the unknown side, and the other unknown side. Now the calculator come by. Yep, I'm using a big one here. I promise I'm not going to use other work with those. So Vx should be equal to square root 17 squared minus 8 squared based on the Pythagoras theorem. The 2 sides equal to the hypotenuse side, so I flip it over. 17 squared minus 8 squared. Then I got 15 for Vx. And then xy is the hypotenuse side. So we have square root 100 squared plus 30 squared. 30 squared plus 100 plus 10 squared. Oh, sorry, this is 16. My bad. All right, let's do it again. Yep, that should become a very good number. So now we got 34 here. So for this way, we have to find out a pair. Looks like, okay, this is my newly found, 15 and 34. Looks like we can find a pair, 6 to 8, 15 to 30, and 17 to 30. The longest to the longest, shortest to the shortest should work. If it don't, try again. So that will be WV equals to YZ, that over that equals to 1 over 2. And then the next one, Vx over xz equals to 15 over 30 equals to 1 over 2. Looking good. So we have the last one, Wx over xy equals to 17 over 34 equals to 1 over 2. So because the ratio is the same, therefore the triangles are similar. More works on textbook, you can go through those, or you can let me know if you want more exercise. But then there's plenty of exercise in the market, so you can go on and try with those. All right, I'm sure your school textbook will have plenty for you to work on. Okay, that's it for the testing similar triangles.